For this video, I will be tackling about the Milankovitch parameters. So, Milankovitch parameters, it explains how the Earth's orbit around the Sun can affect the climate. So, let us know first who was Milankovitch. So, Milankovitch was a Serbian mathematician, astronomer, climatologist, geophysicist, civil engineer, and popularizer of science. And he was born on May 28, 1897. His full name is Milutin Milankovitch. A century ago, Serbian scientist Milutin Milankovitch hypothesized the long-term collective effects of changes in Earth's long-term climate and are responsible for triggering the beginning and end of glaciation periods, or the ice ages. Milutin Milankovitch examined how variations in three types of Earth orbital movements affect how much solar radiation, known as insolation, reaches the top of Earth's atmosphere as well as where the insolation reaches. So these cyclical orbital movements, which became known as Milankovitch cycles. So there are three orbital parameters. The first one is the changes in eccentricity. The second one is the axial precession. The third one is the changes in obliquity. So first, let's tackle about the changes in eccentricity. So the eccentricity measures how much the shape of Earth's orbit departs from a perfect circle. So these variations affect the distance between Earth and the Sun. So the eccentricity is the reason why our seasons are slightly different lengths, with summers in the northern hemisphere currently about 4.5 days longer than winters, and springs about 3 days longer than autumns. So if ang eccentricity decreases, the length of our seasons gradually evens out. So as you can see, mo ni siya ang movement sa eccentricity. Then the next one is the axial precession. As Earth rotates, it wobbles slightly upon its rotational axis, like a slightly off-center spinning toy top. So as you can see, mo na siya ang movement sa axial precession. So this wobble is due to tidal forces caused by gravitational influences of the Sun and Moon cause Earth to bulge at the equator, affecting its rotation. So the cycle of axial precession spans about 27,771.5 years. And then the last one is the obliquity. The angle Earth's axis of rotation is tilted as it travels around the Sun is known as obliquity. So the obliquity is why Earth has seasons. So what are the four seasons again? So it is the spring, winter, fall, and then the summer. So over the last million years, it has varied between 22.1 and 24.5 degrees with respect to Earth's orbital plane. And that's all the three orbital parameters. It is the eccentricity, the axial precession, and the obliquity. And I have here a question. Does the Earth's orbit around the Sun can affect the climate? So the answer is yes. The Earth's orbit around the Sun can affect the climate. Why? Because the shape of the Earth's orbit, known as its elliptical shape, causes the distance between the Earth and the Sun to vary over the course of a year. For example, this is the Sun and this is the Earth. So if Earth is closer to the Sun, the Earth receives more solar radiation, which can lead into warmer temperatures. And then when the Earth is layo sa Sun, the Earth receives less solar radiation, which can lead into the cooler temperature. Yes. So that's why the Earth's orbit around the Sun can affect the climate. And that's all for this video. Thank you for listening.